Okay, so last two key exercises is area between curves. These are very, I would say, popular questions when it comes to integration. So your exam questions often have area between curves, or the one we just did where you have to integrate along the y-axis. So these two skills, I would say, is the bread and butter, but it means that you have to know how to antiderive first, okay, to get to this point. So let's have a look at the theory. What is it saying? They're saying the area between two curves is equal to f of x. In this particular diagram, it's the area of f of x take away the area of g of x with the same interval. And the logic to it makes sense because area of f of x, this is f of x, between a and b, I'm just finding that area. That's what the first line says. So the first line, when you say antiderive f of x between a and b, you're just finding that area. But then if I said, well, what's the second one? Antiderive g of x between a and b is really just this area. So if you actually took the big area minus the small area, well, of course, you're going to have whatever's left over, which is the area between the two curves. So the theory makes sense, but there is one thing that you have to then be careful. In order to use that theory, that means you need the bigger area subtract the smaller area. And the bigger area is the function that has a higher y value within that interval. So whichever function has a higher y value, that's the one that you're going to subtract from the lower y value function. Yeah?
Will they cross over within the area?
Yes. So that goes into this part here. So what happens when they cross? It means you have to split them up. So in this situation here, if f is the red graph and g is the blue graph, that means the interval, when you integrate them, you can't just do integration the whole thing. You actually have to split them up. A to C1, it will be f take away g. But then from C1 to C2, that's now g take away f. So you can see here, this is when f has a higher value, g is a lower value. This is when g is a higher y value, and f has a lower y value. So when you integrate them, this one should be a to c1, f take away g. This one should be c1 to c2, g take away f. Does that make sense? Okay, so that's probably why I'm saying in the exams, I like that. They like to give you those kind of things because, one, they don't give you the graph to visualize. You have to do it. You have to do it on either, you know, the theory in exam 1, or if it's exam 2, you have to sketch it, find the intersections, and then figure out which sections to actually integrate f take away g or g take away f. That's where it comes in. Yeah.
Do they only give you the sketch graphs in exam 2?
No. Exam 1 can have sketching too. Yeah. Okay, so answering this bit here, that's just me trying to describe to you, making sure that it's the higher y value take away the lower y value in that interval. So if you were to fill it up, we can see that it's from C1 to C2. It should be G take away F delta X. Next one will be C2 to C3, and it's F take away G. Okay, and so forth. So you can carry from C3 to B, and then it will be G take away F. Okay? Thanks, team. All right, let's do one example. So if that's the theory, we're just finding the upper value or area, take away the smaller area. Let's have a look at this question. I'm going to pause the video. Now that you've got the theory, we can already tell the linear graph y equals 2x has a higher value. And we can tell that y equals x squared is going to be the lower value. So whatever this is, if I want to find the area between these two curves, it clearly has to be the area of whatever the linear line is, take away the area of the x squared graph. The problem is, what is my a and b? Now, obviously, you can write all that as one interval and say a to b of 2x take away x squared dx. I'm going to pause the video. I want you to find a and b for me, integrate, and then tell me what the area between the two curves should be. So you got a linear graph that is 2x. You got a quadratic graph that is x squared. We've talked about the theory. We can see that it's 2x take away the x squared. But what's the interval? How do you find them? Let's go. Let's check your answers. Did you get 4 and 3 squared units? Hands up if you got 4 and 3 squared units. Good. Excellent. Intersection points were the first thing you needed. You need the interval. So let them equal to each other. I can see some students dividing x on both sides. Don't do that. That's a clear. When you see a squared, you should think about quadratic. So move 2x across, factorize, so you get 2 possible answers. It should be 0 and 2. That's where the 0 and the 2 is. And then integrate. So you integrated, the 2x becomes x squared over 2. The 2's cancel out. So really it's x squared minus x cubed on 3. Sub in 0, which means all of this will be zeros, and then sub in 2's. So f of b minus f of a. 4 take away 2 cubed, which is 8 on 3. And what's that? 3 times 4 is 12. 12 take away 8 is 4. So it's 4 out of 3. You can if you had that sort of understanding. Most students who just divide don't have that understanding, and they'll just write x equals 2. And then with the diagram, they can tell it's 0 there. All right. Challenge your understanding now. So you got the theory, how to find area between curves. I want you to have a go with that VCAR 2011, just on the back of that page. That one gets you to think a bit. Don't get intimidated by the symbols, A's and M's, but I want you to think for a bit. I'll give you about, because it's a 4 marker, let's give you 6 minutes. That's the time that you would take on the exam. So let's give it 7 minutes for 1 minute reading, and then see if you can do it in 6 minutes. Okay, so 7 minutes in total. Flip over the page. See if you can figure it out. The answers come out nicely. At first it feels tricky, but it's a nice question to do. So here's the question. Similar to the previous example I did with you, first thing you needed to find, you need to find the intervals. Intervals, 0 to m, find the intersections first. So to find the intersection, you let f of x equal to g of x. And this is what you should have to start off with. F of x equals g of x. Here's your cubic. Here's your linear. This is what I was saying before. Don't divide the x's. That's what students generally do. Move the values across. You're meant to factorize and solve. So moving minus ax on both sides then becomes minus 2ax. Take out the x as a common factor. And we can use null factor law now and saying x could either equal to 0 or x squared minus 2a equals to 0. From here, you can then solve. So again, add 2a on both sides. Square root 2a, you should get a plus or a minus. But based on the graph, we can tell that x or m has to be the positive root of 2a because clearly the graph has 2 points where they could equal. So one's a negative, one's a positive side, but they intersect. We know we're taking the positive side. So hence, you should have x, which equals root 2a, or m, as your higher interval should be equal to root of 2a. Can I get a show of hands who got at least the interval? Okay, so you need 0 to m, so root 2a. So now that you got the interval, they told you that the shaded region is equal to 64. So g of x take away f of x. That's the values that I'm looking for. Higher y value take away the smaller y value. So 0 to m or 0 to root 2a. The area has to equal 64. It's g of x take away f of x. That's the modeling. Then from here, once you modeled it correct, it's about you simplifying correctly. So with the minus signs, I like to be careful with double negatives. So minus and minus ax becomes plus ax. So I get 2ax minus x cubed. And now it's an integration. So from this step, antiderive. Antiderivative of x is x squared over 2. But the 2's will cancel out. So you have ax squared. That's add 1 and then divided by whatever the power is. So it's 4 and 4. You got the intervals from 0 to root 2a, so here we go. I'm going to substitute root 2a in, but notice when you sub 0 in, it's just going to cancel all out. So I didn't bother subbing in 0, I just substituted root 2a into the equation. This step here was interesting to see how many people can do it by hand. Remember, it's exam 1. Root of 2a, but then squared. The squares and the square roots should cancel out. So you should have 2a times a. This should simplify to 2a squared. This one really just means square the root 2a and then square it again. So if you already know that this is 2a, and you square it again, that just means 2a all squared. It should be 2a times 2a, 4a squared. And so we're putting it all back over here. That's 4a squared there, and I just realized I could have simplified 4 before. I didn't do that. I actually just times it all by 4, so I could have made my life easier from that step actually, but I didn't. I times them all by 4, and then I subtracted them. So 8a squared minus 4a squared, give me 4a squared, and then divide both sides by 4. Brings me back to 64 equals a squared. Square root both sides to find a. A should get plus or minus 8, but since they already told you a is greater than 0, a must be 8. That means m must be root of 2 times a. So 2 times a is 16, but then root of 16 is 4. So a should equal to 8 and m equals to 4. Nicely. Can I get a show of hands who got all 4 marks? All right, not too bad. All right, so the process was the same as the example I did before, except it's just a bit of playing around there. But that was a nice question to have a look at. I'll stop the video